Alright, hi guys. We're starting chapter 4 in geometry now, and chapter 4 is where we're going to really start talking about angles a little bit more in detail. So the first lesson out of the chapter, 411, has to do with taking a little bit of concept that we know from algebra about slope and kind of melding it with geometry, looking at the angles. So let's refresh a little bit about what we know about slope. First of all, slope is a way of measuring the steepness of a line. So I'm going to write that down. It measures the steepness of a line. Measures the steepness of a line, which we learned in algebra. And a lot of times when you're taught about slope, there's all these different ways you can remember it. Some teachers kind of use the old saying, rise over run, as a way of measuring slope, which works pretty good. Another way, a little bit more mathematical way of saying rise over run is we use a Greek symbol called delta, delta y over delta x. And the delta symbol, this thing, the Greek letter stands for change. So this means the change in the y over the change in the x. And either way works. Either formula is pretty good, either way of remembering. So we're going to make up a couple examples. Let's just try a problem here. Let's say you had y equals 1/5 x plus 2. And I said, okay, can you graph this line? It's obviously in the format y equals mx plus b. So I can say that m, my slope, is 1/5. And b, my y-intercept, is 2. So to graph this line, no big deal. I'm pretty good at graphing. So why don't you go ahead and pause the video for a moment if you need to. And draw a nice graph. Use your graph paper and really set this up good. I'm going to do the same thing while you guys are working on it. You want a really nice graph. And I'm going to focus on the first quadrant. I'm not going to do all 4 quadrants for this graph. So we've got plus 2 as our starting point. So 2 on the y-axis is going to be the first point of my graph. So I'm going to make that my first point. And we've got a growth of 1/5, which means we go up 1, and then 5 over. 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. We could kind of just keep doing this for as long as we felt like it, really. So let's add some scale numbers on here. Guess we don't need a totally perfect graph. I just want a nice straight line. So I'm going to line this up, use a ruler, try and make my line as nice as I can. There we go. Put a little arrow on the end, and we're going to work with that. So last year in algebra, this is what you learned how to do. You spent a lot of time graphing lines, which is all good. I'm glad we can graph lines, but now we're going to do more with it today. We're going to start measuring the slope and then talking about the angles that are formed by it. So something you're going to be doing in class is you're going to be doing something like drawing your slope triangle or your growth triangle and measuring it. Like we already know that we counted 5 over and one unit up. That's why we had this number in our rule, y equals 1/5 x. And so this is my delta y and my delta x. So when I write slope down here, I'm going to write it as delta y over delta x. The change in the y-axis, this is the y-axis right here, and the change in the x-axis. So if you look at the delta y, we have a change of 1. If you look at the delta x, we have a change of 5. So we get this 1 over 5. Hence, it's in our rule. Well, what we're going to be doing today is we're going to be looking closer at this slope triangle. I'm actually going to kind of like zoom in. I want you to think about it like that. Is like we're going to get really, really close. And I want to study inside of this triangle, this little angle right here. I know something about this angle. I know it's 90 degrees. It's totally a right angle. But I don't know the measurement of this angle. So one of the ways we can figure it out is we can use one of our protractors from class that we've been doing. I can estimate this angle. I'm going to have to kind of guess because the protractor isn't 100% precise, but it's not bad. So I'm going to use one of these. I'm going to line it up and try and measure this angle. So pause the video, get out your protractor, and do the same thing. Try and measure this angle. See if you're capable of getting a good estimate. Okay, I'm going to do the same thing. So if you've forgotten how to use a protractor, first of all, you're going to line the bullseye in the center with the point. So I'm going to line up the bullseye. Then there's these arrows on the protractor. I want to get the arrow lined up straight with the bottom of the line here. So like that. Cool, that's pretty lined up. I don't know if you can see it on the screen very well. And then what I'm going to do is I'm going to follow my red line and just kind of see where does it look like it's at. And it's like it's right above 10 degrees. You're probably having a hard time seeing that, but it looks like this angle is about 11 degrees if I had to guess. So I'm going to write it looks like it's about equal to 11 degrees. And I need to name that angle. It was an unknown angle, so we can use a variable. One of the most famous variables, I don't know if famous is the right word, but a famous variable for an angle that we don't know is called theta. It's another Greek letter. It looks like this. Kind of looks like a 0 with a little loop in it. And we're saying that theta equals 11 degrees. That angle is about 11 degrees. Approximately, so I use the squiggly equal sign because it's not exact. But it looks like about 11 degrees. So if I change this growth triangle and said, well, I have all these points on my line. What if I had built a bigger growth triangle? What if I had said, instead of going over 5 up 1, what if I'd gone like over to this 2 points over and gone like over 10 squares up 2? So over 10 up 2. Now I would say that the slope of my line is 2 over 5. So I'm going to write down below here, slope equals delta y over delta x, which is now 2 over 5, or 2 over 10, excuse me. Turns out 2/10 and 1/5, well, those are equivalent. If you were to turn 1/5 into a decimal, you can use your calculator and do that. You can divide 1/5, and it's 0.2 as a decimal. Same with 2/10. If you divide it in your calculator, it's 0.2. So we have equivalent ratios here. We have a great proportional setup where these triangles must be similar. They have the same ratio on their sides. If I asked you what this angle measured, you're going to say, well, if they're similar triangles, it's the same as this one. These angles have to be the same. So this must be 11 degrees, approximately 11 degrees. So when you get into class and you're working on this, you're going to have to be able to kind of draw some lines and measure these angles. And one of the questions that you're going to be asked is, are all lines, do they all have the same angle in this corner? Does the slope really affect it? Could I change the slope and still get 11 degrees? That's the big question. So you know how we had this y equals 1/5 x plus 2 rule? I'm going to modify it for this next problem. Why don't we try a different one? Let's do y equals 3/5 x plus 2. Just going to change that rule up a little bit, and I want to graph this line and figure out the angle of the slope triangle. So I'm going to draw a graph again. And again, you can pause the video if you want to have more time to set up your graph. We're going to start at 2. So 2 is our y-intercept. And now our slope is 3/5. So I'm going to be going up 3 over 5. So 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And I could do this a lot. I'm only going to do it a couple of times, and I'm going to draw a line here. Alright, so there is my y equals 3/5 x plus 2 line. Not the best graph. I haven't labeled all the scale numbers and everything, but I'm more concerned with the angle today. So let's put some details on here. Starting with, let's put on a slope triangle. So I'm going to connect the first 2 points with a 90-degree slope triangle. I can add on my measurements. This is delta y. It's 1, 2, 3. So delta y equals 3 units here. On the bottom is delta x, 1, 2, 3, 4, 5. So delta x equals 5. And what I'm curious about is what is theta. What is this angle in the corner? So is it the same as the last problem? Is it still 11 degrees, even though I've changed the rule for the line? So let's get out a protractor. Pause the video, measure with your protractor, and see if you can figure out how to get this angle. See if it's still 11 degrees. Okay, so I'm hoping you paused the video, you got an answer. Now I'm going to go over the answer up here. I'm going to put my protractor on my graph. I'm going to line up my bullseye and line up my arrow and try and get an accurate measurement. It's going to be a little bit of a guess. So let's see here. Here's my lined up. Looks pretty good. It's above 30 degrees. Do you see that? It looks like 31 to maybe 3, maybe 33 if I had to kind of guess. So I'm going to say I think that the measurement of angle theta is approximately 33 degrees as my guess. So remember I asked you a question earlier. I said, what if I change the rule for the line? Does it change the angle? And I think the answer is definitely yes. Now instead of 11 degrees, it's 33 degrees. So this angle, which we call the slope angle, really depends on what the slope is. Slope changes the angle. So we're going to write a little note down here. And we're going to draw a picture of a line and draw on this line 2 points and connect them with a slope triangle and measure it, label it theta. And then this is my delta y and this is my delta x. So I'm making up a generic line, a generic picture, and I want to say that this theta, this angle, depends on delta y and delta x. They're related to each other in some way. So theta depends on delta y over delta x, the slope. Theta depends on slope. Bigger slope changes the angle. Smaller slope changes the angle. So you're going to learn more about this in class. You're going to try a few problems and hopefully kind of get the hang of this. One skill you really need is being able to measure with your protractor. So if you're still kind of confused on that, you should ask in class, have your teacher help you out. Have me help you out, and I'll show you how to do this. All right, hope that helps. See you in class.